Hi, everybody, and good afternoon. Good Thursday afternoon. Bryan Norcross here from Fox Weather, and it's our weekly Q&A here for hurricane season, and we're going to take your questions. And I have a guest today who is kind of Mr. Hurricane. He has done just about everything, and if I ever have a question about anything about a historical hurricane or how hurricanes are analyzed over the Atlantic or a million other things, I call Dr. Chris Lancy of the National Hurricane Center. He's the chief of what's called the Tropical Analysis and Forecast Branch. It's probably, Chris, the most important branch of the Hurricane Center that nobody's ever heard of in the general public. So, welcome to our Q&A.
Thank you, Brian. Really appreciate the opportunity to chat with you today.
So, Chris, among so many things, has been the lead scientist, I guess you'd say, on a project to reanalyze past hurricanes. So, what kind of statements are made about what happened 100 years ago, or what happened 30 years ago, or any kind of past hurricane? The group of scientists and forecasters and researchers that Chris is part of, and this has been going on for years and years, has gone through all of the data available for every storm going back to 1851, and it is that database that we reference. So if you have any questions out there about any kind of hurricane in the past, anything to do with past hurricanes, including Hurricane Katrina, of course, we're at 20 years from that experience, and we'll talk to Chris about that. And one reason that Chris is so apropos for this discussion is that he's very key in what's called the hurricane FAQ, that if you Google online for the FAQ page and you have a hurricane question, you'll probably come up with answers that Chris was part of, besides lots and lots of other things. So, Chris, it's great to have you here. Let's talk about what's going on in the tropics right now. And by the way, I should say, we're streaming once again on Facebook, YouTube, TikTok, X, Instagram, and LinkedIn. So we're trying to cover all the bases here to be sure that we can reach everybody and give the audience a way to talk to us. And this is really in preparation for a big storm, so that we have a two-way communication, kind of like we used to do by telephone. But of course, people don't use the phone anymore. So this is it, and we're reaching out the best we can. All right, so what's going on out there right now is we have this area to watch that is a 20% area to watch. The system is not even expected to come off the African coast until late in the weekend, Sunday-ish, and it has this kind of window of opportunity to develop there, and that's it. In the Atlantic, there's this big cold front here along the East Coast. It's pushing off the East Coast. That's really got a big dip in the jet stream associated with it. That anything that gets out in here in the foreseeable future is going north. So this is kind of an interesting Labor Day that we don't have any real systems to talk about. And even this one out there is a long way from doing anything, and it probably is not going to do anything, as I'll show you more on that in a second. But look at the Pacific. This is interesting, I think, because the Pacific is kind of active again. And these systems over here, we thought one of these might develop for a while. So you have systems kind of flaring up south of Hawaii in the central Pacific, and the eastern Pacific starting to get a little more active. And as we've seen already this year, that after the Pacific gets busy, sometimes the Atlantic gets busy. And there's a good reason for that, and we can talk with Chris about that. But it is interesting that two systems here have a reasonable to decent possibility of developing into at least a tropical depression, if not a tropical storm or something stronger. Now, something new to show you here that we're just introducing at Fox Weather, and Chris, I doubt that you've seen this. What we've done is we've taken what are called the ensembles, and the ensembles for any model are running the model over and over again with a little bit of different starting point and seeing what kind of spread you get. If you watch Fox Weather, we call that forecast uncertainty in the spread of the models. Well, we've taken the European, the American GFS, and the Google AI model, and the spread of each one of those ensembles, that's about 130 elements, and then produced a track with it by using kind of normalizing where it is at each time step. So, and we went ahead and did this, by the way, because the analysis on the Google model for Aaron was very, very good. And I want to hear Chris's opinion of that in a second, but I'll show you what we see. So when we start this, we're essentially starting where we are now, more or less. And you see this was Juliet over here. This one up here was Fernand. And now both of those have died out. All right, let's go forward in time and watch what happens here. And let me take this writing off there. And here you can see that system coming off of Africa. And notice it kind of flares up there, goes up to 40% according to this analysis. Hurricane Center has 20%. And then it kind of dies out here because it gets into more hostile wind. At least that's the thinking right now. But anyway, this is kind of verifying what the Hurricane Center is looking at, that's the area where something might develop. Over here around Florida, this notice very low odds. Light blue is down in the 10% range. That's something related to that old front that's going to sit down there. This is Fernand heading off, and it's dying now. And then here are the two systems in the Pacific that might develop. That was old Juliet. So anyway, something new to look out there, Chris. So what's your impression of the success of the Google model on Aaron? I mean, this is all new business here, but that was pretty impressive.
Yeah, 2024, we are just taking baby steps into AI versions of the computer models. This year, we have a suite of them available at the National Hurricane Center, and we're incorporating them into our track and intensity and size forecasts of the storms. And along the way, we're trusting but verifying. We want to see how well they
Mhm.
work before we really change our methodology with a lot of consistency. But we're monitoring them, and we're taking a look at how they're verifying. Especially for Aaron, they did do a good job on track and to a limited degree on the intensity.
I saw the work that James Franklin did to compare the models, and the only AI model I saw on his chart was the Google DeepMind AI model. Do you have any idea if any of the other ones, the one that people look at online called AIFS, which is the European Center AI model, or I mean, there's the Aurora model from Microsoft. There's the is it Pangu, the Chinese model, and anyway, there are a variety of them. Do you have any idea if the other ones were verified as well as the DeepMind model?
If these groups are making them available to us, we're going to be verifying them because we
Right.
want to see how well they perform in real time. Sometimes when researchers give us results, they look too good to be true because they are. But
Mhm.
in this case, it does look like the AI versions of the computer hurricane models are working quite well, and we're starting to incorporate them more thoroughly. We will do an end of the hurricane season evaluation because you get a whole bunch of samples and you get a really robust idea of how accurate they really are.
Yeah. Let's just talk about your current job and everything that the this branch of the National Hurricane Center does that kind of happens behind the scenes that is so important for our understanding of what's going on in the oceans and the forecasting that your group does in the ocean. All right, tell us about the group and what you guys do.
So the branch that I lead up at the National Hurricane Center is called the Tropical Analysis and Forecast Branch. It's kind of a mouthful, TAFB. And
TAFB,
we
yeah.
have 16 marine forecasters that don't just predict during the hurricane season, we do it all year round. And we're responsible for a big chunk of the tropical North Atlantic, the whole Caribbean, the whole Gulf of America, as well as the East Pacific. So we have 10 million square nautical miles that we forecast for every day. And we're providing wind forecast, waves, if there's issues of visibility, whatever the mariners have to deal with out over the open ocean, we're providing them forecasts for them to stay safe.
And I know a number of the forecasters at the National Hurricane Center came through your unit. So it's great, really, training for understanding data and analysis that is such a big part of forecasting. Let's talk about Hurricane Katrina. So 20 years ago today, it reached Category 5 strength, and I can remember that day. We thought it was going to intensify, but the Category 5 really was a surprise. Where were you at that time? What's your memory of that lead up to the landfall in southeastern Louisiana and in Mississippi?
20 years ago today, I was a hurricane researcher, and I was part of the Hurricane Research Division of NOAA that's based also in Miami.
Hmm.
And part of that is we jump aboard the hurricane hunters that the Aircraft Operations Center works out of Tampa at the time.
Hmm.
And I was on several missions into Katrina. I did 3 flights on the Gulfstream 4 jet around the hurricane. And on the day before landfall, I had finished the third of 3 flights. The last one was over the Gulf, and I was prepared to go home. And I got a call at the Tampa airport at the last minute from my boss, Frank Marks,
Hmm.
saying, "Hey, looks like the Aircraft Operations Center is going to do a landfall mission on Katrina. Do you want to help out?" And of course, I'm like, "Yeah, I want to be there." So it was get up
Wow.
middle of the night, jump aboard the Orion P3, and we're flying. And as you mentioned, Brian, it was a Category 5 the day
Hmm.
before. And we were very happy aboard the aircraft because we could see it was weakening. It was, it was no longer a 5. It was either a
Right.
5 or 4 or 3. And so we thought naively that there was not going to be a disaster in Mississippi and
Yeah.
Louisiana. What we didn't appreciate at the time was how giant it was, that the
Yeah.
hurricane force winds extended way out from the center of the storm, and that massive amount of kinetic energy was going to shove that storm surge inland across Mississippi and Louisiana. So it was really saddening to see the aftermath where 1,500 people died in Katrina in Mississippi and Louisiana because of that storm surge from the Gulf as well as Lake Pontchartrain.
Was the increase in size related in to the decrease in intensity? I mean, because the pressure was still extremely low. So I always say that the lower the pressure, the more energy there is in the system. And so if you spread that energy out, you end up with weaker winds, but more spread out energy. I mean, we saw this in Sandy. We saw this in Aaron. Low pressures and not super high winds. But is that what happened in that last run up to landfall in Katrina? Essentially, did it grow in size in that last 6 to 12 hours?
It grew in size dramatically,
Yeah.
and the reason for it is a little uncertain, whether it was going through a concentric eye wall cycle or was just doing the natural progression as hurricanes as they go poleward, where it starts to evolve into an extratropical cyclone that
Hmm.
that always are much bigger in size. But regardless of the cause, the effect was a big area along the coast with hurricane winds and the commensurate storm surge that was pushed ashore by the strong winds.
Yeah, 28 feet of storm surge in Mississippi. I mean, I was there after Camille in 1970, in February of 1970, driving from Tallahassee over to New Orleans for Mardi Gras. And half of Highway 90, there was no I-10 then, half of Highway 90 was gone. And so they had two-way traffic on the westbound side of Highway 90. And I mean, it was obliterated through from Biloxi on through Gulfport and past Christian and Bay St. Louis, as far as you could see from the road looking north into the town. And I know folks from there thought, okay, that was it. That was the benchmark of all time. And then Katrina happened, just you know, within one lifetime, really, another uh, stunning storm in southern Mississippi, and then of course the levee collapse, the flood wall collapse in New Orleans, um, and so forth, and everything that came of that. Jordan, have we got any questions in from any of our listeners here today?
Yeah, so we have a couple of questions coming in from different viewers across the country. I think I'll start off with this one. You guys were just talking about it. Kyle, I would absolutely love the opportunity to fly into a hurricane with the hurricane hunters. And I bring it up because a lot of people always talk about they want to go on a hurricane hunter flight, but what is it actually like?
Yeah, what's it like, Chris?
Yeah, so for 10 years I flew both the Orion P3s as well as the
Mhm.
Gulfstream 4 jet into and around hurricanes every season. The G4 is more like a commercial airline. It is a jet.
Mhm.
And you typically fly in the periphery around the hurricanes. And the idea is to monitor the whole atmosphere, at least the troposphere, by launching dropsondes. And so those aren't as exciting. For me as a meteorologist, I love them because you can map out and you can make a great forecast just with those measurements from the dropsondes that you're
Mhm.
providing. But it's the Orion P3s that go right through the eye. And the way they do that is they don't go over the hurricane. They can't because they're turboprop aircraft. They go
Right.
right through the middle. And so it's imagine being in a car wash with the lights out and you're on a roller coaster all at the same time. That's kind of what it's like.
Yeah.
You're getting buffeted around. You don't feel the swirling winds, the spinning winds. What you feel is the turbulence, the up and down
Mhm.
motions. And for Katrina, it was extremely turbulent getting into the eye wall, and there was convection that goes, or thunderstorms that go out, 150, 200 miles from the center. It was a very large system, as we mentioned,
Mhm.
and so it was bumpy the entire time as we were making the landfall mission.
Yeah, so I mean, they have radar on the plane these days, so that they try not to go through the worst of it, I guess, right? To some degree, aren't they looking for some kind of a gap to get into the eye wall if it's possible?
Yep, that's the idea. You want to
Yeah,
not go into the most hazardous conditions possible, but if you're getting into the eye of a strong hurricane, usually it's got a complete eye wall, and
exactly.
so there's
Yeah.
not a lot of weak spots to go through typically. And indeed, in the early years of the hurricane hunters, from the 1940s to the 1960s, they typically did not go into the eye for strong hurricanes. They would approach it, they would paint it with their nose radar,
Mhm.
and then they're like, "That's where it is, but we ain't going in there because it's just too dangerous for us." So, since the 1970s, there's more routine that we do fly into the hurricanes. But one aspect for safety, we only fly at 10,000 feet, 2 miles
Yeah.
above the ocean, because if the pilots lose control of their plane, which often happens for a few seconds, they're able to regain control and stay safe. But yeah, it is quite the experience getting to fly. Typically, it's only those folks that are researchers. Occasionally, we do get the forecasters on board, but usually, when there's hurricane flights, our forecasters are busy. And occasionally, they'll take news media aboard as well.
Yeah, TV weather guys sometimes go on those things. But, what you just mentioned is important, I think, when we talked about the historical record, and nobody knows more about the historical record that we have for hurricanes than you do. The fact that the data collection systems that were used, even in relatively recent times, where we actually know there were storms there, going way back, a whole bunch of storms, no doubt, happened that we really don't know existed because they were out in the ocean somewhere. But the fact that the data collection technique by aircraft has changed, doesn't that change our certainty about what was going on in the hurricane, how strong it was at the time that we weren't actually penetrating into the eye and measuring what was going on there?
Oh, without a doubt. The technology infuses our ability to understand what's going on in a hurricane, including how large and how strong the winds are. You go back further in time and you just don't have the capabilities to actually see what's happening there. So, for example, they have dropsondes on the aircraft now that I mentioned.
Hmm.
Those can accurately measure the winds, but it's just for a spot, just for one
Hmm.
little location, and only for a few seconds. You go back further in time, and you did not have those available before about 1997. The aircraft measure the winds really well at that 10,000-foot elevation, but those aren't the same winds that are felt at the ocean or when the hurricane comes ashore on land. And so, yeah, so we've got great measurements of winds at that level, but how do we adjust those down to the ocean surface? And that's still a process that we use today. And we've only had accurate flight level winds for all the aircraft since 1990. for the NOAA aircraft goes back to the mid 70s where I have accurate. And, before the 60s, you didn't have satellites either. And so we had
Right.
no clue of where the hurricanes were. They would actually send aircraft out of the Lesser Antilles near Puerto Rico looking for hurricanes to the east before the
Yeah.
satellites were there. That was their mission. Go see if there's anything out there without knowing if there's a storm at all.
Yeah, well, famously in the great Labor Day hurricane, here we are, Labor Day of 1935, the Cuban Meteorological Service sent an American guy up in well, not much more than a biplane. It might have been a biplane. I don't know. He went out looking for the the incredible hurricane that ended up just completely destroying the Middle Florida Keys, or just north of the Middle Florida Keys, I guess, around Alamorada today, Matacumbe Key. He anyway. They sent this guy in an airplane up to see if they could go find the storm, and he found it in a place that they weren't expecting it to be, and that actually did provide some alerting to that storm wasn't going to go past Key West. It was actually going to turn to the north, as I recall the story.
Yeah, it's you look back on the historical, jumps, and often
Mhm.
it's things that are done as a fluke. It's so the routine aircraft reconnaissance began in World War II, basically as a bet between some of the pilots from Britain and some of the pilots from the United States.
Mhm.
And they flew out of Arlington, Texas, got into a hurricane that was offshore Texas, and the weather officer was so impressed, he demanded that the pilots take him back out there. And then at that point, they realized it's actually fairly safe to fly into hurricanes if you have enough altitude. And that kind of process had continued through the Air Force to the Navy and NOAA as well. And it's invaluable information that we get, but we haven't had that really since World War II is where it started.
Yeah, yeah, Colonel Duckworth, right? Then I think he actually flew through the storm when it was over Houston, if I recall. He could look down through the eye and see, see the city because of the war. They weren't reporting on where the hurricane was, and so it was all everything was new information there. All right, Jordan, what do you have?
Yeah, our next question is why does it get chilly outside when hurricanes happen in the Atlantic Ocean?
Hmm.
Well,
Okay.
I mean, I think that this is all right. Correct me, Chris, but I think we're transporting air from aloft to the surface when you have any kind of significant downpour of rain. You pull air from aloft, and the stronger you pull, the stronger winds from aloft, even right. This would I mean, I can sort of so I can feel this. What I'm thinking, I'm trying to think of what's jogging me here. Maybe it was Wilma though. That was a little different thing because that was a late year storm, and essentially Wilma pulled a cold front through South Florida.
Yeah.
Anything
My
strike you there with that question?
Yeah, my guess is in the outer part of the hurricane, you're having sinking air. So it's
Hmm.
it's called an in, up, and out circulation.
Hmm.
And that sinking air dries up all the clouds. And as
Right.
a hurricane is approaching, it is hotter than heck and humid as heck. But you tend not to have a lot of rain. And
Right.
then as the storm gets there, you're getting the rain bands and the air is cooled off substantially because of that. So certainly it's not a cold front, but
Hmm.
it's because you're actually starting to get the rain cooled air as the core of the hurricane gets closer to you.
Yeah, and in Wilma, it was effectively a cold front because the back end circulation was a north wind, and it was late October, and I mean, look at Sandy, which was that hybrid storm, of course, had all that cold air on the west side, and
Yeah,
that,
Wilma for me was great
yeah,
because we lost power for 10 days after Wilma being here in Miami. But because of that cold front, it was a legitimate early winter season cold front.
right.
For the first 3 or 4 days, it was beautiful out. but then it
Yeah.
went back to the soup and it got
Yeah.
kind of nasty again.
Well, so yeah, so I lost power. I was living in Miami Beach at the time. I lost power for only 4 days. So it was great because I had this battery thing that I could run a fan all night with the battery thing. And I'd take the battery thing into the TV station where we had a generator and I'd plug it in and charge it during the day. And then I'd go home at night and put the fan on and have the slide. I was living in a condo then, sliding glass doors open. And it was in the 60s outside. It was magnificent. It was the nicest post-hurricane weather I think any of us ever experienced. All right, Jordan, what else do you have?
This one from Daisy. How long does it take for a wave to develop into anything when it comes from Africa to reach the U.S.?
All right, Chris. I mean, there's an average, I guess, right?
Right. So we get about 60 of these tropical waves a year. They usually start in May and continue all the way through November. So it's once every 3 to 5 days we'll get these waves coming off, and most don't turn into a tropical storm or hurricane. If the conditions are ripe, especially August, September, they can form pretty soon off of the African coast. And so we've seen that where you get a storm form even just a couple days after it leaves Africa. It is pretty rare for a storm to form near Africa and get all the way to the United States.
Mhm.
Typically, the farther east a storm forms, the less likely it'll reach the United States because those storms are always trying to turn north, and you have to have a strong subtropical ridge to kind of keep them in place and moving toward the west.
Yeah, you have to have a blocking high because they respond to any kind of little dip in the jet stream if there's a strong storm. But I think where the question was going is what's the average time from the time a disturbance leaves Africa till it would get to the U.S. if it came to the U.S.? I mean, my sense is that that's in the 10 to 12 day range. Do you know, is there an official average on that?
Yeah, so longitude of Africa, West Africa, is about 20 west.
Hmm.
Longitude of Florida is 80 west. So that's 60 degrees of longitude.
Right.
And typically a wave moves about 5 to 6 degrees a day.
Hmm.
So if it's moving 5 degrees a day and it's 60, so it's about 12 days or so.
Yeah. Yeah. That was my sense of it too. All right, Jordan.
All right, our next one coming from Joe on YouTube. Whatever happened to the GFDL model? I believe it was one of the more advanced models when it was first introduced in the 90s. Was it formally retired or did it evolve into another model?
Well, the geophysical, what laboratory?
Fluid,
Dynamics,
fluid dynamics.
fluid dynamics laboratory. That's right, at Princeton, produced that. I mean, I know they're still the lab is still working, right? But are they not in the model? No, they're still doing something, right? But maybe not in a daily model. Where does that stand? Do you know?
So they brought about the GFDL model,
Right.
and it was a great success as one of the very first hurricane focused models. We call them mesoscale models that are kind of just the hurricane, not global weather. And it led to the development of the Hurricane Weather Research Forecasting, or HWRF model.
Mhm.
And eventually, as HWRF left GFDL in the dust, at one point, it didn't make sense to run the GFDL model anymore because it just didn't have as much skill. So there are researchers at GFDL that are still involved with the next generation hurricane models, as well as global model development as well.
Yeah, I know. I've seen talks about them. I mean, it's a real high level group there at the GFDL lab at Princeton. Jordan?
All right, so this one, I am not very familiar with this, but I'm sure you guys are. Hi, Brian. Leonard Povey flew a Curtis Hawk biplane fighter and found the Labor Day hurricane. He didn't try to fly into it, but he did verify that it had turned away from Havana and would strike the Keys. So that's an interesting
Right.
story.
So Willie Dry, wrote the book on one of the great books, but a great book, The Storm of the Century on the 1935 Labor Day hurricane. And Leonard Povey, the name was like stuck in my brain. Leonard Povey was the American guy that the Cubans sent out. The Cuban Meteorological Service was extremely advanced, and even into the 30s. Father Benito Viñas. These names of the past I'm losing it today. But Father Benito Viñas, who started the the Havana Observatory was a Jesuit priest, and the Jesuits were very science-minded. And he was brilliant in the 1870, I think 1876. He made his first forecast, and he would publish forecasts in the newspaper. And the Cubans went, "Wow, he was brilliant!" But he was smart enough to look at the clouds and the way the tides were and know something about that. And he set up telegraph systems across the island and had spotters sending him back to the observatory. If you go to Havana, which is a much more difficult thing now than it used to be, there was a time when it was easy to go there. Uh, they have a shrine essentially to Father Benito Viñas, and his counterpart in Manila did very similar things. Another Jesuit priest whose name I don't recall at the moment, but anyway, it was an amazing thing. But that the legacy of Benito Viñas extends to today. Actually, the Cubans are very aggressive and active and excellent at weather forecasting. I know at the Hurricane Center, you interact and share data and so forth with the Cuban Met Service.
Yeah, we work with all the countries in the Caribbean.
Right.
All of them have their own weather service. And you're right, the Cubans have many, many decades of outstanding forecasters and insight. Looking back on Padre Benito Viñas's work, when you read the English translated
Yeah.
stuff, he knew, for example, in the 1870s, that hurricane low-level clouds spiraled inward. The ones that are the kind of the alto stratus were spiraling without an inflow, and he knew the cirrus up aloft was going outward.
Yeah.
And he used that to figure out where storms were, and then the change of that over time. Brilliant, brilliant work. I mean, compared to our forecasting abilities today, is very primitive, but it was the very first scientific approach for making forecasts, and they were successful.
Yeah, I mean, he was a star. Jose Rubiera you probably know Jose, right? Or I've known him for many years. Jose was the superstar of Cuban television for decades, and I can remember getting in a taxi cab in Havana and having them, what are you doing here? Oh, it's a convention of meteorology, meteorología, in español. And oh, you know Jose. Yeah, everybody in Cuba knew Jose and believed Jose. He was remarkable. He was a great uh, guy, and he's still active. I still see him online now and then. Yes, but the Cubans led the way in so many ways. In fact, I mean, you can tell the story better than I, but let me tell a little bit of it. Maybe I'm sure you know a lot more, Chris, about the 1900 Galveston hurricane.
Mm.
That at the time there was real tension between the Cuban Met Service and the U.S. Um, whether was it the Weather Bureau then, or what
Yes,
was it still? Weather Bureau, I guess, by that
yes.
time, right? And in Washington, and there was a political issue because the Americans had essentially taken over Cuba, but the Cubans knew more about hurricanes than the Americans did, and the Cubans didn't like the forecast that the Americans had put on the 1900 hurricane, which was to turn up into Florida, I think, or turn north. Somehow, right? And the Cubans said, no, it's going west. So you want to finish that story or tell me what I misremembered?
Right. It's an amazing story of how today you wouldn't believe it'd be possible, but the U.S. Weather Bureau at the time in 1900 lost the storm. They
Mm-hmm.
did not know where it was going. And partly it was because the ships at the time did not have two-way radio. The very first report from a ship out over the open ocean to say back to shore was in 1909. And so the Weather Bureau in the United States didn't know that it had gotten into the Gulf and was intensifying and moving toward Texas. The Cubans, though, they were spot on. They knew it was,
Yeah.
but because of this political differences, and I think a little bit of hubris by the Americans that we thought we knew better, they disregarded the Cuban forecasts, and unfortunately, the storm did get to Texas. It devastated Galveston. and thousands of people died. You know, when you look at what was available, the technology was so much in its infancy, but it was a very vulnerable area. Lots of people living on a barrier island that was very low elevation, and a massive storm surge overtook the whole island.
Yeah, that's another incredible story, incredible book about the 1900 hurricane. Yes, I mean that the whole political issue was so bad about who was in control and so forth that the Cubans weren't allowed to use the telegraph to send their message out. It was a horrible thing, which reminds me of the wasn't the 1919 hurricane, the sort of great Corpus Christi hurricane that they kind of lost as well for a while after it passed the Keys, and then was heading toward Corpus Christi, and there was some question of how big it was and what was going to happen.
Yeah, unfortunately, that was really common in the early part
Mhm.
of the 20th century to have really no idea of how strong a storm was. Certainly, with the advent of the two-way radio on ships, that you had an idea of where the storm was, but those ships were doing their best to get out of the hurricane.
Right.
They knew with their barometer, if it was lower, they need to go the other direction. And so you knew that there was a system, but you had no idea if it was just a large tropical storm or if in the middle was a major hurricane.
Yeah, there was a cruise ship actually that tried to get into Havana Harbor during that storm, and it ended up sinking in the Florida Keys. It's actually a dive site now that you can go see. That was it's one of those mysterious things that this ship went down. It was a horrible tragedy, but they never found any people. They just found the ship. So it's one of those spooky things that they talk about in the Keys. All right, Jordan.
Yeah, so this is coming from our TikTok audience. The TikTok audience is asking about shear, wind shear. How does it impact hurricanes? One person said it seems like people are always talking about it and it's a headache, but what is it? What is it? What is wind shear?
Well, so Chris, I'll let you address that because you talk about your discussions that your group does talk about the winds over the Atlantic all the time, and I know you analyze. I mean, wind shear has got to do with the difference in the flow at different levels of the atmosphere, but there's also the issue of good trough, bad trough, and we saw there's a lot of I know scientific discussion about the times like in Michael when we saw what we thought was a pretty high shear environment
Mm.
that the storm goes ahead and intensifies anyway. So shear is not shear is I guess the lesson of that the thing that we typically say is the difference in a fairly low level and a fairly high level, but sometimes other levels come into play that can be even more important.
Yeah. Yeah. Vertical shear, again, that's the change of winds with height, usually
Mhm.
from near the ocean surface to about 8 miles up. So you're looking
Mhm.
at basically the tropopause.
Mhm.
And ironically, hurricanes don't like strong wind shear. Anything more than about 20 miles per hour usually puts the brakes on their spin up or can cause them to start falling apart. Um, Almost the entire hurricane season, you're having systems in the low latitudes traverse warm water, and most of the time they're in a lot of moisture for them to access,
Mhm.
but it's the wind shear that's usually the aspect that dictates it. And as Brian said, sometimes you're getting these moderate shear cases, and those are the really challenging ones because depending on the circumstance, you could have moderate vertical shear that tears apart a storm, or it could still intensify a bit. And those are the ones that we're hoping the newest generations of hurricane models can better distinguish for us, because those are the most difficult forecasts. Where when it's low shear, warm water, a lot of moisture, it's going to explode, kind of like what Aaron did over the open ocean. If it's cool water or dry conditions or a lot of shear, it's not going to form, or if it is already formed, it's going to fall apart. But it's those ones in the middle, those are the really challenging
Mhm.
cases.
Yeah, and in the early part of the hurricane season, we have the Saharan dust and whatnot. So sometimes the upper level winds or the shearing winds are blowing the dust into the circulation, which can slow it down when the system gets near land. Sometimes the circulation, dry air comes from the north, But in the middle there, there's nothing to stop it if the conditions are right, right? And so that's what happens when we get into September is that the Saharan dust generally goes away, so we're more likely to have the primo conditions for systems to develop, and that's why we have the peak of the hurricane season nominally on September 10th.
Yeah,
Jordan?
we're fortunate that strong hurricanes are pretty rare in the Atlantic, Caribbean, and Gulf. We only average 3 per year.
Mhm.
And as one of my former bosses, Professor Hugh Willoughby, who's at Florida International University, he used to say hurricanes are like people. They very rarely live up to their potential. And thank goodness that's
Yes.
true with hurricanes, because imagine if we had 10, major hurricanes, category 3, 4, 5 every season. That would be hard to imagine and hard to deal with. But just having 3 can be a real challenge, as everybody knows that lives on the coast.
Well, and so you could have the every season, and sometimes that has happened where you've had multiple strong hurricanes hitting the coast in a season. 1893 six in my mind, 1886 maybe. But you can also have kind of repetitive hurricanes like the late 40s in South Florida, where it seemed like every year, well, was it 45, 47, 48, 49, and 50, you have a category 4. And in 47 and 48, you had a category 1 as well, all hitting South Florida. So all kinds of repetitive things can happen. Jordan?
All right, so our next question, getting into the forecasting, what's coming up next? Do we have a prediction for the next El Nino?
So interesting. So the Climate Prediction Center came out with their updated forecast this month. I mean, they update it every month, indicating an increased chance of a La Nina before the end of the hurricane season. It's not a slam dunk, but they put that as the most likely condition because we're in a cool neutral now. So I was saying earlier in the year, if you had to put odds on it, you would think the second half of the hurricane season would be busier than the first half, just based on that more than anything else. What's your take on that, Chris?
Right. So when you look at the hurricane season, it's 6 months long, but 90% of the strong hurricanes are just in August, September, and October. So it's a very narrow annual cycle. And even though we've only had one hurricane thus far, and we're going to be getting to September very soon, it doesn't tell us much at all about the second half of the season. And last year's a great example of that. We had this huge lull, right, from August to early or mid-September, and we're thinking, oh, maybe we blew it on the seasonal forecast and it's not going to be a busy year. And then, oh my gosh,
Yeah.
we had Milton and we had the hurricanes,
Helene, yeah.
Helene, that gets into the North Carolina, and it was extremely busy. It was one of the busiest second half of the hurricane season ever. And so yes, it's been nice that we've not had any U.S. hurricane impacts thus far. It ain't going to last. We still think it's going to be very busy for the remainder of the season. Maybe not for the next week, but beyond that, please stay tuned and be ready to take action, because I would be shocked if we didn't have several more hurricanes.
Yeah, as I wrote today, it's not over until it's over, right? Now, and last year, I mean, that was really weird. The weather pattern over Africa was so weird. The warmth and the upper atmosphere, which doesn't make the storms grow in the same way, was weird. And then there was this forecast during the lull of the MJO, which is this pulse that goes around the Earth every month or two and can enhance or suppress, emphasis on can, enhance or suppress activity. And it was forecast to come around about the middle of September. And we said, we're just waiting around for the middle of September because then we're going to see what the MJO does. And it did, right? And I mean, I've talked to Phil Klassenbach about this. Was that it? It was really the difference between 0 and 100 really just the MJO? I mean, probably not, but we're kind of in a similar routine this year, right? Where the MJO, but the MJO can vary in intensity too. It doesn't have to be a strong pulse. is due to come around again to the Atlantic sometime second week of September, middle of September, something like that.
Right. And so when you have the background climatology of the conditions tend to line up from especially mid-August to mid-October of most amount of moisture, least amount of vertical shear, strongest waves coming out of Africa,
Mhm.
and very warm sea surface temperatures. If it's a little suppressed, it can cause it to be quiet. But if it's a little enhanced because of this Madden-Julian oscillation,
Mhm.
all heck could break loose. And
Yeah.
so that's the concern. If they stay all over the open ocean, like Aaron mainly did, then it's more of a concern for mariners. But if they form closer to the United States, or if the steering patterns take a storm over the open ocean and head us to the United States, then it's going to be busy for all of us.
Yeah, I know you love your mariners, but that was an amazing threading of the needles with Aaron finding that track. I know that we've had tracks just offshore. I mean, a lot of them just offshore of the U.S., and there are good reasons for that, I guess. But that was we were really very, very, very fortunate that a storm that big didn't have significant impacts on land. Jordan?
Yeah. What if I could
Yeah, go ahead,
comment
Chris.
that
Yeah,
the one of our main customers are mariners, whether it's
right,
cruise ships, it's cargo ships, oil
right.
tankers, folks with giant personal yachts, and we can actually monitor them through their satellite transponder. And it was gratifying to see all the mariners getting out of the way of the storm, not just where it's at now, but the projected track as well. And it means that the mariners over the open ocean are getting the forecast and taking appropriate action so that they don't get hurt, or they don't suffer property loss. And so that's really neat when we can see our customers actually doing the right thing to stay safe.
Yeah, now they can get it. Now so many ships, in fact, I guess pretty much any ship has satellite internet now, and they can get real data. I mean, we've had these horrible tragedies in Hurricane Joaquin and in Hurricane Mitch, where ships were lost because of complicated set of misunderstandings and taking a chance and failing actually and losing the ship and losing the crew and so forth. But now people can be informed, and it really is your team that informs them and keeps them safe. So it's fantastic. Jordan?
Yeah, so while we're kind of talking about it, just wanted to give you guys a shout out. People are really enjoying the questions. They're learning a lot that you guys are talking about. For those that are watching, we'd love to hear where you're from. Type in the comments where you're watching us from, all that kind of stuff, what you think, all of that. Our next question here is from Florida. We got a couple people from Florida asking generally about the forecast, and then this one, I'm curious as to why South Florida hasn't seen a hurricane in years. I'm talking way over 10 plus years. It's like there's a shield. They always turn to the north or stay south and into the Gulf.
So this kind of gets to the bigger version of that question. If you're not South Florida focused, is do we know why, like in 1954 and 55, the storms all seem to go to the Northeast and New England, and lately they've all been in the Gulf for I mean for years. It's not just a little tiny stretch. It's actually a significant stretch. Or in the 40s, so many in South Florida. Actually, you could there was that whole stretch. Well, in the 20th century, from the first decade to the 60s, so 7 decades, seven eyes came over downtown Miami. Not to mention the 1947 Fort Lauderdale hurricane and other hurricanes, that the 45 hurricane and that was significant in Dade County and other ones. But do we have any sense of why, if that seems to be the case, Chris, of that these long-term patterns, is it sunspots, or it feels like there's some kind of long-term cycle on top of the short-term cycles in some mysterious fashion?
Yeah, you're certainly right. There's a perception that I have as well that there's clustering in time of either
Mhm.
clusters where you don't get hit in areas like South Florida that we've not been hit since Irma, directly by a strong hurricane, And then there's periods where you get whacked repeatedly at the same area. So, for example, Florida in 2004 and 5, Louisiana in 2020 and 2021, repeated same areas being impacted.
Yeah.
I don't think it's random, but we don't know as meteorologists or climatologists why that's occurring. I think it would be a great PhD study to uncover what is causing that, because I don't think it's random, but I don't understand what's causing that. We do know that there's a couple of ingredients to get a landfall. First, where does the storm form? And the closer a system forms to the coast, the more likely it's going to hit that coast. Makes sense. But then there's the steering flow on top of that. And typically, to get a system from the Atlantic to make landfall in the southeast US or the mid Atlantic or New England, you've got to have a pretty strong ridge that's going to push the storm there. Did we have that, for example, in the Carolinas in 54 and 55, where you had 5 hurricanes hitting that same area? Probably. But what's causing that? Is there any overall forcing factor? And is it predictable? There's probably 4 PhD theses right there that need to be
Right.
done. But it's a great question. We see this clustering, and nobody knows why.
Yeah, and when you talk about, I mean, Miami specifically, since Miami has been transformed into this, just I don't know, it looks like Hong Kong just about. I mean, it's a sort of a smaller version of Hong Kong. It's this incredibly dense high-rise city sitting there. You fly into Miami, and it looks all you can see is water. I mean, water, and it looks like the land is 3 inches above the water. It's amazing, and the city is sitting right on the water. But if you think about, downtown Miami has been hit by hurricanes, as I said, 7 times, and I went over in the 20th century. But in terms of big, I don't mean just strong hurricanes. The 1950 Hurricane King was a Category 4. I think you guys upgraded it right to a 130-mile-an-hour Category 4. But it was a little tiny hurricane. I mean, an incy tiny hurricane, right? That hit downtown. But the airport, as I recall, do I recall this right? The airport didn't have much. West Day didn't have much. And Miami is a very small city, east to west. So I mean, it was exceptionally small hurricane. You really, somebody asked me recently that works with the governments and so forth about Miami hurricanes. I said, there really hasn't been a bad one since 1926. I mean, a
Mm,
really bad one, right? I mean, 1926 Miami hurricane, Great Miami Hurricane was just such an exceptional storm, and then it almost got repeated in 1928 when the storm went farther north and turned it into the Lake Okeechobee disaster after being a huge catastrophic event in Puerto Rico. But these giant storms, Irma type storms,
yeah.
right? Um, that we haven't had that in Miami since 1926. That is debilitating over such a large area that if it happened today, how would you how do you begin to recover? Because the thing about Andrew, for example, which was obviously catastrophic in South Dade, folks from North Dade and Fort Lauderdale could go to South Dade and help almost immediately to some degree, to the degree they could. But if you have a regional disaster like the 1926 hurricane, everybody is fending it themselves, and you have disruption across the entire metropolitan area. So it's daunting to think about.
Yeah, it's amazing how hurricanes are so different. And
Yeah.
that maybe is one aspect that the public doesn't quite understand. You have a category 5 hurricane like Andrew, and it's tiny. The eye was 10 miles across. That's it. And folks in Fort Lauderdale, they barely had a category 1 because it was so
Right.
small. And our ability to forecast these size changes, and whether this is going to be a violent small hurricane or a violent large, are very immature. We just don't do a good job of that. And so you're right. If we have a big, like a Katrina, that makes landfall
Mhm.
in Miami, or as you mentioned, the 1926 Great Miami Hurricane, it's going to make it a lot more difficult. I'm hopeful that the building code has been upgraded since
Mhm.
Andrew, or especially since the 26 storm, and that it's been, the inspections are occurring and we're adhering to it. But there's so many more people living in Miami-Dade County now. What is it, 2.5 million people, that
Mhm.
even if only a quarter of the homes have, major to complete damage, you're still talking about tens of thousands of homes, maybe even more than we had during Hurricane Andrew.
Yeah, and I think the threat that we haven't seen in Florida, that is very real in a densely populated place like Miami, or it could happen in Tampa, as well, is the stranding issue. So you had a 1926 hurricane where the ocean water came over the beach communities. You would have people in those buildings with their cars wrecked in the streets and no ability to get out, maybe with no power, no water, and no communications, and really no ability for ambulances to them because the streets would be deep in sand and debris and so forth. And it could happen, obviously, in the city as well. Biscayne Bay floods and there's debris in the streets, and people are safe in the building, but they can't, they're stuck in the building. We haven't had that yet, but to me, that is one of the many big threats of a big hurricane affecting a big metropolitan area. I mean, Wilma was the example. When Wilma happened, in what, it was a category 1 in Miami-Dade, right? Category
Yes.
2 in parts of Broward and Palm Beach County, right? It was the third most expensive hurricane in the history of hurricanes in 2005. So it was Katrina, Andrew was, it had been Andrew, but then Katrina, Andrew, Wilma. I mean, and this is a category 1 and 2, but it hit an incredibly populated, densely populated place. It just makes it's exponentially more complex.
All right.
Yep.
Yeah, go ahead.
Go ahead.
Go ahead, Bryan.
Go ahead, Chris. What were you going to say?
Yeah. Okay.
It is daunting about what could occur. And one would think, with the technology we have today and the infrastructure, that we're not going to have a situation in the United States again where people are on their own and up and need to be taking care of themselves for days at a time, and maybe even longer than that. But you're right. The scenario of a very strong, very large hurricane hit direct impact in a major metropolitan is a really scary scenario, and it's not inconceivable, whether it's, Houston or New Orleans again, or Miami, or places that haven't had major
Or
hurricanes
New
that aren't
York.
as big. New York, yes, yes.
or Cape Cod, or yes, up the. If you study the history of hurricanes in the Northeast, I mean, they've had a lot of hurricane disasters that, if they happened again today, would be extremely daunting to deal with. Jordan, sorry, go ahead.
Oh no, no worries. So everybody get their questions in. We don't have very much time left, so let's get the questions in. But I wanted to bring this up. You guys might be familiar with it. This is Dr. Isaac, I believe that's Klein.
Klein,
Yeah,
yeah.
did tracking of the Great Galveston Hurricane of 1900. I know you guys were talking about Galveston a little bit ago. So
Yeah, Isaac Klein was a complicated figure because he was very wrong about whether Galveston could face a hurricane, but he ended up being uh, quite an instrumental researcher and a tremendous figure later in his life. I think he transferred to New Orleans, wasn't it, after his time in Houston?
Yeah, he is a bit of a complex figure, as you mentioned, because there's a bit of a debate about his role during the hurricane of Galveston 1900. Certainly before the storm, he downplayed the risks because he thought that the water being really shallow off of Galveston meant there was less risk from
Yeah.
saltwater flooding from the storm surge. And the physics was actually the opposite.
Right.
Because it's so shallow, it was more at risk for a devastating storm surge. But there's a book by Eric Larson called Isaac Storm, where he makes the case that Isaac Klein exaggerated his role in saving people during the storm itself. Because he made claims that he helped rescue lots of folks and get the word out, But the evidence is a bit more inconclusive on that. Today, he is held up as an amazing researcher. After the fact, he became the foremost storm surge researcher in the United States and had a great career for another 20 years. But it's still a bit unknown of really what happened there in Galveston in 1900 for Isaac Klein. It was certainly a personal tragedy. His wife passed away in the storm surge.
In the storm surge in their home. Yeah. Yeah, that's a great book, Isaac Storm. The thing that has always been perplexing to me about Isaac Klein, and he told the city fathers in Galveston that they were safe. They did not need to build a seawall, which they, of course, did after after the hurricane 1900. But just before that, there was used to be another port and that was competed with Galveston actually for goods being manufactured in Texas and whatnot, called Indianola, and it was south of Galveston, kind of halfway or so to Corpus Christi, I guess, and that town was almost obliterated in 1875 in a hurricane, and then completely obliterated in 1886 in another hurricane, and they gave up on the town. And they moved it inland. I mean, so, and with big storm surge and all of that. So to me, that was just a big mystery about how he could have thought that Galveston was somehow immune when Indianola had been just, destroyed, completely destroyed. And yes, the issues about, wasn't he supposed to be riding on a horse warning people or some kind of thing, and nobody, happened to see that after the fact. I mean, it was a very, very complex situation because it was thousands of people dead in these piles of debris. So it was
Yeah. It may be partly the psychology of disasters, where even someone objective as a scientist like he was could have been caught up. Well, a disaster can't happen here where I live.
Yeah.
And so maybe even though, as you said, Indianola hurricane 1875, 1886 doesn't exist anymore because of those hurricanes, wasn't that far away. But it's possible that because of the impact that he would feel, that he just thought that it wasn't ever going to occur. And of course, it was a fatal mistake for many people because of that.
Do you have any idea what was known about storm surge science? So now we know that the Gulf is very vulnerable from all the way from Florida around to Texas because of this shallow shelf that lifts the surge up essentially and accentuates the surge. So it's so different on the west coast of Florida or elsewhere in the Gulf than it is on the east coast of Florida, for example, where we get much bigger waves. Still storm surge for sure, but much bigger wave action. When did that science, come about? Do you have any sense of that?
It came about in part because of Isaac Klein in the 20s and 30s.
So it was after the fact, after the 1900 hurricane.
Right. So what we understand today, 90% of the storm surge is just due to the frictional forcing of the wind on the water, where it's basically shoving the water ashore. 5 to 10% is the inverted barometer effect, where the lowered pressure allows the height of the ocean to go up a
suction,
little bit.
Essentially.
Yeah, yeah. So we do know that if the hurricane is hitting perpendicular to the coast, the storm surge is going to be worse because more time pushing that water ashore. The storm surge is going to be worse if it's a slower moving system, again, because there's more time pushing that water to the coast. And the storm is going to be worse if it's really shallow because that water is more easily pushed over the coastline. And so places like Tampa, for example, are extremely vulnerable because of how low lying they are and how shallow the water is offshore. And we've seen the opposite effect with a couple of hurricanes, where because the hurricane hit south of them, they had offshore flow and Tampa Bay emptied out.
Right.
If the hurricane makes landfall in the Gulf just north of Tampa, it's the opposite. And we're going to see incredible flooding that hopefully people will be aware of in advance and get out of the way.
Yeah, Helene might have done folks in Tampa a big favor because there was a storm 100 miles offshore or so, moving parallel to the coast, and it flooded. It was the biggest flood in many years in Tampa Bay. And just imagine a repeat of the 1921 hurricane, or I mean the 1848 hurricanes. They had two hurricanes in 3 weeks that put big storm surge in Tampa Bay. So it can happen. It doesn't happen that often, but it seems to be happening more. All right, Jordan, we have a few more.
Yeah, well, maybe one of our last ones here. It's a great one to kind of finish it up. You guys can both kind of talk about it. Thomas would like to look ahead. Another on the way. So is there another tropical threat brewing, or what are we tracking?
Well, we're tracking a system that's forecast to come off of Africa late in the weekend, and it has a so-so chance of developing into something. But and then there's another. If you look at the long-range models, another system sometime after that that maybe has a little more promise. But right now, we're basically not tracking much of anything. How far, in your mind in advance, do you think about these things, Chris? I know the Hurricane Center has a very strict set of, okay, we're not going to talk about it more than 7 days out for good reason, because you start going too far and you're just wrong so often that it really affects your credibility and so forth. But what's your gauge of looking at the models, saying, "Oh, that's maybe something that we ought to pay attention to"?
Yeah. As we're looking at the 20th anniversary of Katrina right now,
Mhm.
it helps to look back at what we were doing 20 years ago,
Mhm.
during the span of my lifetime and my career. We were doing a 2-day tropical weather outlook, but it was all qualitative, all wishy-washy. All
Mhm.
right. And eventually we're like, well, no, we need to make that quantitative, at least put probabilities on there, chance of development. And we did that for 2 days. And then we were like, well, the models are getting better. So let's go to 5-day forecasts on the tropical weather outlook. And then a couple years ago, we're like, wow, the models keep improving. Let's go all the way to 7 days. And so
Mhm.
a couple years ago, we started doing a 7-day tropical weather outlook, mainly because of the skill of these global weather models and their ensembles. So can we go out further in time? I think yes, eventually.
Sometimes,
I certainly
yeah.
I look at the
Mhm.
models because they run them out 2 weeks, sometimes even a month in advance. Um, it's not quite prime time for us to go beyond 7 days for formations of storms, but I can certainly see where that could be possible in the future.
And we, just like you said, hurricanes, everyone is different. Every uh, uh, you know disturbance is different in its potential to develop, right? Because some of them really fool you, right? They look like they're going to develop and they don't develop and they go ahead and develop anyway. And there's a lot of work to be done. I know Dr. Bob Hart at Florida State does a lot of work on Genesis and why some storms develop and other ones don't. And that, again, more PhD projects, I think.
And
Yeah.
that's one of the reasons why we don't say, yes, it's definitely going to develop, or
Right.
no, it ain't. We're just not that good. And so that's why we do more of this probabilistic or chances of formation. And when you look at our track record each hurricane season, we're pretty reliable. So, for example, if we say it's a 70% chance of forming in the next several days, you look at enough cases and about 70% of them do actually form. So it's fairly well calibrated and reliable. So we can certainly improve. It would be nice to get to a point where we can say definitely it will form or definitely won't. But my guess is we probably won't ever quite get there.
Right, right. Because the atmosphere is chaotic, and by definition, you can't absolutely forecast a chaotic system, right? I mean, that's the
Exactly.
theory. The theory, anyway. Just before we go, Chris, you were a student of Dr. Bill Gray, the amazing Dr. Bill Gray, as so many of the great hurricane researchers and people that you run into went through Colorado State, and even to this day went through Colorado State. What made Bill turn out such good people, or Colorado State turn out such good people? I mean, I went to Florida State, and Florida State turned out good people too. But the legacy of Bill and his predecessors there, I guess, what brought Bill to Colorado State has been stunning, is maybe not even strong enough.
Right. When I was graduating UCLA in 1987, I knew I wanted to focus on hurricanes for my graduate work. And there was a few schools, including Florida State, that I applied to and was interested at. But the opportunity to work with him, and at that point, he had just started the seasonal predictions a couple years before, and I was so intrigued about that opportunity to make forecasts that actually worked months in advance. And so I applied, I got in, and I was able to work with him on seasonal forecasting and climate change questions on hurricanes. And of course, living in Colorado, going to Colorado State, it's a pretty beautiful place as well. So it was a great 6 years of my life there.
Yeah, yeah, yeah. He was an amazing man. It was a great place. I was very honored to know him there for many years and to visit him at Colorado State. And of course, very good friends with Dr. Phil Klotzbach now, who has picked up that mantle, and is he and Michael Bell and team there are still at it, and still always coming up with new thoughts and new ways to do it. So, all right, Dr. Chris Lancy from the National Hurricane Center and TAFB, and does the great work of analyzing what's going on by satellite and forecasting offshore. We don't talk about TAFB enough, I don't think, and the work that you guys do. So thanks, Chris. Really appreciate you having being with us this afternoon.
Well, you're very welcome, Brian and Jordan. Appreciate the chance to talk to you in depth about what we do and some of the historic hurricanes, and hoping we stay safe this season, both over the open ocean and on shore. But we still have a little more than half a hurricane season to go, so we'll see what happens.
Yeah, and that second half maybe looks like, odds are a little bit, that is going to be busier than the first. All right, everybody. Thanks for tuning in, and be well. And we're planning to see you again next week, unless something weird happens. But we'll keep you up to date on all your social media channels. Take care.